Michael, good morning. Today, me and my teammates would like to present about the regressive analysis and hypothesis using variable. This team consists of 3 members, which is Azalina as a group leader of our team, followed by CP, and last but not least, which is me, Pushri. So before we go to the introduction part, let me define what is regression. Regression analysis is defined as a statistical method that can be used to explore relation between species and environment. On this basis of observation, we could also see the environmental variable as a series outside. So next, what is Herzberg two-factors? Herzberg two-factor theory, which is defined as a job satisfaction that influenced by 2 categories, which is hygiene factor and multi-vector factor. So hygiene factors such as work environment, work condition are essential to prevent dissatisfaction, but do not have in a long-term satisfaction. In contrast, multi-vector factors such as recognition are directly contribute to job satisfaction and motivation. By applying this method to this framework, this study about investigate how environment such as hygiene factor and multi-vector factor that affect job satisfaction among T-life employees. The study employs a quantity research methodology using a structured questionnaire which is distributed via Google Forms to collect data from respondents. The questionnaire includes items to measure job satisfaction, work environment, recognition, and work condition, as well as demographic variables such as age, gender, education level, and years of experience. Each independent variable is accessed through 4 targeted items that are designed to capture about the perception of the employee to get the infection list. The method that we are using for doing this task is by using IBM, SSPS27, and the Excel. Go to the part for 3.0 standard deviation. As you guys can see the minimum and maximum point. The table displays about the 4 variables, which is work environment as known as WE1, WE2, WE3, and WE4. Each are tested for the work environment for the t-test. For the mean WE, which is 3.7667 with a standard deviation of 0.99774. For the mean WE2 is 3.700 with a standard deviation of 0.8872. For the mean WE3, which is 3.7000 with a standard deviation of 0.82954. And lastly, for the mean of WE4, which is 4.0833 with a standard deviation of 1.71997. Next, for the t-test for R1, which is for the recognition, is mean 3.7167, and for the standard deviation, which is 0.86537, and for the R2, which is 3.8500, and for the standard deviation, which is 0.18978, and for the R3, which is 3.8833, and for the standard deviation, which is 0.84556, and lastly, for the R4, which is 3.7500, and standard deviation for 1.01889. Work condition, which is state as C1, C2, C3, and C4, are also being tested for the work condition for the t-test. For the mean C1 is 3.6833 with a standard deviation of 0.87317. For the mean of C2 is 3.7833 with a standard deviation of 0.86537. For the mean C3 is 3.8167 with a standard deviation of 0.67627. And lastly, for the mean of C4 is 3.8000 with a standard deviation of 0.93519.
The normality test evaluates whether the data for various constructs follow a normal distribution. 2 statistical tests called Kolmogorov, Smirnov, and Shapiro-Wilk are used here, and their results are presented for the construct. Work environment, the table displays 4 variables, WE1, WE2, WE3, WE4. Each test for normality. Both tests p-value less than 0.001, indicating that the data for this variable significantly divide from a normal distribution. Recognition. For variable R1 through R4, the results are consistent, with p-value below 0.001 under both Kolmogorov, Smirnov, and Shapiro-Wilk tests. This suggests that recognition-related data is also non-normality distribute. Work condition. Similarity variables C1 to C4 also show p-value below 0.001 for both tests, further confirming non-normality in this construct. In conclusion, since the p-value for all tests are below 0.05, it suggests that none of the data set follow a normal distribution. This correlation matrix highlights the relationship between 4 constructs: job certification, JS, work environment, WE, recognition, R, and work condition, C. Correlation value, the correlation coefficient ranging between 0.770 and 0.870 indicates strong positive relationship among all variables. For example, job certification, JS, and work environment, WE, have a correlation of 0.770, recognition, R, and work environment, WE, show a correlation of 0.848, work condition, C, correlative strongly with recognition, R, at 0.870, significance p-value. All correlations have a p-value above 0.001, which imply that the relationship are statistically significant at the 1% level. Sample size N. The sample size for all correlation is consistent at 16 respondents. In summary, the present combination analysis reveals significant and strong positive relationship among the constructs, supporting their interconnection in the study. Cronbach alpha is a measure of external consistency, indicating how closely related a set of items are as a group. A higher alpha value, typically above 0.7, suggests that the items measure the same underlying construct reliability. First, work environment. Reliability statistic. The Cronbach alpha for the work environment construct is 0.832, which indicates good reliability. This suggests that the 4 items WE1, WE2, WE3, WE4 are consistent in measuring the construct. Items total statistic. Each item's correlation with the total scale is strong, with value ranging from 0.516 to 0.784. If any item is removed, the alpha remains high between 0.748 and 0.845, indicating that no item significantly reduce the scale reliability. Scale statistic. The mean of the scale is 15.2500 with a variance of 7.953 and a standard deviation of 2.82018. This statistic describes the distribution of the work environment responses. Recognition ability statistic. The Cronbach alpha for the recognition construct is 0.890, reflecting excellent reliability. This indicates a high level of internal consistency among the items R1, R2, R3, R4. Item total statistic. The corrected item total correlation range from 0.737 to 0.763, demonstrating strong association between each item and the total score. Removing any item result in alpha value between 0.844 and 0.867, which suggests the overall scale reliability would still remain high even if an item were excluded. Scale statistic, the mean is 15.2000, which a variance of 9.553 and a standard deviation of 3.09072. Reliability statistic. The Cronbach alpha for the work condition construct is 0.850, indicating good reliability. This shows that the items C1, C2, C3, C4 effectively measure the same underlying construct. Item total statistic. The corrected item total correlation range from 0.677 to 0.796, reflecting strong consistency between individual item and the overall construct. Removing any item would result in alpha value between 0.814 and 0.869, which suggests that the scar reliability would remain high. Scale statistic. The mean is 15.0833 with a variance of 75840 and a standard deviation of 2.80007. The Cronbach alpha value for all construct work environment 0.832, recognition 0.890, work condition 0.850. This demonstrate high internal consistency. This support the reliability of the item used in the scale and indicate they are suitable for assessing their respective construct in the study. The coefficient table provides detail about the relationship between the independence variable WE, R, and C and the dependence variable JS. Key element includes unstandardized coefficient. This value indicate how much the dependent variable is expected to change when the independence variable increase by 1 unit, holding all other variable constant. For example, for WE, the coefficient is 0.192. For R, the coefficient is 0.272. For C, the coefficient is 0.514. Standardized coefficient beta, this value have compared the strength of the predictor on a standardized scale. Here, C has the highest beta value, 0.450, suggesting it has the strongest influence on JS. Staticity and significance. This indicate whether each coefficient is statically significant. P value below 0.05 suggests the predictor is significant. Only C is significant. P equal 0.006, while WE and R are not significant at the 0.05 level. Collinearity statistic, tolerance and variance inflation factor, value check for multi-collinearity, high correlation among predictor. VIF value above 5 might indicate problematic multi-collinearity. Histogram and related statistics analyze the residual difference between observed and predicted value. The histogram suggests that the residual are approximately normally distributed with a mean close to 0, 1.53 until 16, and a standard deviation of 0.974. This support the assumption of normality in regression, a key requirement for valid result. Together, this result provide insight into the regression model, showing which predictor significantly impact the dependence variable and the model's overall reliability.
Next, we move to multi-collinearity calculation. So, for the tolerance, is indicate variance unexplained by other variable. So, for the values, W we got 0.239, R is 0.196, C 0.207. So, result for variance inflation factor, VIP is WE we got 4.184 and C 4.825 is acceptable. So, for the R we got 5.089. It's moderate multicollinearity. So the conclusion is recognition show moderate multicollinearity and other within acceptable limit. Next is collinearity diagnosis. For the condition index, dimension 3 we got CI is 26.785. It's a moderate multicollinearity. For dimension 4, condition index is 29.303, close to strong multicollinearity. So for the variance populations, high population is greater than 0.5, indicate multicollinearity. So the conclusion moderate to strong multicollinearity observed in dimension 3 and 4. Okay, so next we move to hypothesis, which is the purpose of this hypothesis testing is to make conclusion about the population using sample data. So for the we need to compare two hypotheses, which is null hypothesis, HO means no significant relationship or differences exist, and 2 is alternative hypothesis, H1 is we have a significant relationship or differences exist. So the objective in this study is to determine relationship between variables work environment, recognition, and work conditions, and their impact on job satisfactions. So for the result test is the work environment significant, highlighting environmental impact on performance and well-being. So for the recognition and work condition, which is it shows differences increasing their role in shaping employer experience. So the Pearson correlation analysis, we got the job satisfaction and work environment strong positive correlation underscore the role of supportive environment. For the recognition and job satisfactions, we have a positive correlation highlight the importance of acknowledgement. So the work condition is favorable condition positively influenced by key. The Cronbach alpha, as for result, we found that the high Cronbach alpha values across work environment, recognition, and work condition confirm that variable measurement tools. This is consistent issue that the findings are not merely coincidental but reflect to true underlying patterns. So for the regression analysis, we found that positive confidence shows significant relationship, which, for example, recognition enhance the satisfactions. For the for the R squared, we found that high S squared indicates strong predictive power of independent variable. As for conclusion, the comprehensive analysis of hypothesis testing result offer valuable insight into the factor influencing job satisfaction and related outcomes. And significant t-test result strong correlation, reliable regression model, and validated assumptions collectively support rejecting the null hypothesis in favor of the alternative. This finding underscore the importance of fostering and supportive work environment, providing recognitions and enhancing work conditions to improve organizational outcome and employee experience.
So that's all from our presentation. Thank you.